Hi, Rajan this here. Welcome to the channel. So today we'll discuss how to solve problem asked in today's LeetCode Weekly Contest 474. So let's start with the first problem. It says you are given an integer array nums that consist of unique integers, and originally nums contained every integers within a certain range. However, some integers might have gone missing from the array. The smallest and the largest integer of the original range is still present in the nums, right? And we have to find out all the missing integers in this range in a sorted order, and if no integer is missing, so we have to return the empty list. So the thing is, there is a range, so let's say the range is from L to R. So your minimum value and the maximum value, that is L and R, will always be present in the nums, and in between this L to R, some integer may have been missing in this original array nums, right? So what you can do, you can just find out what is the minimum number in this num and what is the maximum number. Then you can iterate through all the numbers from L to R, and you can check if the number is present in this nums or not. If the number is not present in the nums, then it means that the number is missing. For example, here, if you see the minimum number is 1 and the max number is 5, it means that all the numbers are supposed to be present from number 1 to 5, but see, 3 is not present, right? 1 2 3, 3 is missing, 4 and 5 is anyway there. So, and we also know that the minimum and the smallest and the largest will always be present. It means that we can also iterate from L plus 1 to R minus 1, because L and R will always be present, right? So from index, from number 2 to 4, so from 2 to 4 only 3 is missing, so see. And similarly, let's say this example, 1 and 5, so mean value and the max value, so we can iterate from L plus 1, that is 2, to R minus 1, because L and R will always be present. So from 2 to 4, actually 2 to 4 everything is missing, so that's why your answer is 2, 3 and 4, right? I hope you understand. This is a pretty easy implementation problem, so directly look at the code. So here is the code of this problem. So what you do, you first sort the nums array, then you find the minimum value and the maximum value. So these two number is your range, right, from L to R, and L and R will always be present in the original array nums. So what you can do, you can create a missing vector, so you can find out all the missing numbers. So iterate from L plus 1 to R minus 1, because L and R will always be present in the nums. Then what you can do, so once you sort it, your minimum would present at the end and the maximum would present at the last, right? That's why you find the minimum value at the 0th index, nums of 0, and you can find the last value from back function. So nums.back would give you the last function. Now iterate through L plus 1 to R minus 1, and since the array is sorted, you can apply binary search to check if a number is present or not. So apply binary search, nums.begin, nums.end, and that current value I. So this will be true if I is present in the nums array, otherwise it will return false. So if it is false, means the number is not present, then it means that this is a missing number. So just push it into the missing vector, and at the end return this missing vector, right? So yeah, I hope you understand. Now let's look at the second problem. In second problem, you are given an integer array nums. You must replace exactly one element in the array with any integer value in this range, minus 10 to the power 5 to 10 to the power 5 inclusive, right? And after performing this one single replacement, we have to determine the maximum possible product of any three element, right? And these three elements should be from three distinct indices in the modified array, and we have to return the integer that denotes the maximum product achievable. So for example, if you see in the first test case, minus 5, 7 and 0, what you can do, like you can replace 0 with minus 10 to the power 5. So once you replace 0 with minus 10 to the power 5, now you can find these three numbers and you can multiply them. So if you do multiplication, you would be getting this number, right? Similarly here, if you see minus 4, minus 2, minus 1, minus 3, what you can do, you can replace either minus 2 or minus 1 with 10 to the power 5. So after doing that, your operation, your array would look like minus 4, minus 2, and let's say I replace this minus 2 with 10 to the power 5. So you can get this such a large number. You can also replace minus 1 also with 10 to the power 5. So in that situation also you will be getting the same max value, right? But here if you see, like if you replace since we have to replace exactly one number, so like it won't be possible that you would like you can avoid 0. So like you would be having 1 0 for sure. That's why your output is 0 here. Yeah, it's a good problem. Let's see how we can approach it. In second problem, we are given an integer array A, right? And we can replace any element from this array A with any of the number in this range minus 10 to the power 5 to 10 to the power 5, and we have to find out the maximum multiplication of any three numbers, right? So if you notice it here, it will always be optimal for sure that like either you choose minus 10 to the power 5 or 10 to the power 5. It will never be optimal if you choose any number in between, right? So let's say you want to choose minus 10 to the power 4, for example. Then why cannot you choose minus 10 to the power 5? It will anyway like give you the maximum result. So I hope that's clear that it will always be optimal to choose either minus 10 to the power 5 or 10 to the power 5. Now that was first point. Now the second point, if you notice, see, we have to replace one of the number with either 10 to the power 5 or minus 10 to the power 5. What it means? It means that let's choose three numbers from here, x, y, and g. X, y, and g, right? Let's say I replaced one of the number with 10 to the power 5 or minus 10 to the power 5. Let's suppose case number 1. If the multiplication of other two numbers, the unreplaced number is negative. So in that situation, what we have to do, we have to replace the remaining number like with minus 10 to the power 5, so that the total product would become maximum and positive. So in that situation, your answer would be positive number, right? Positive and the max possible for sure, because we have find out because we have multiplied with 10 to the power 5 here. Now case number 2, let's consider. If the multiplication of two number, the unreplaced number is positive, right? In that situation, what I'll be doing, I'll be replacing the remaining number with 10 to the power 5. So in that situation also your number become positive and maximum possible, right? What it means? It means that the dependency of two unreplaced number is like it could be either negative or positive, because if the number is negative, we can again make it positive by taking minus 10 to the power 5. If the product of two numbers, two unreplaced number is positive, then we can multiply with 10 to the power 5. So again your number become positive. So we don't have any dependency whether the multiplication of two unreplaced number is positive or negative. It doesn't like necessarily has to be positive or negative. It could be either both. And we know that the number could be negative if one of the number is negative. For example, let's say y is the number which is replaced. So this is the replaced number. Right? What it means, if the number is negative, like if the multiplication of x and g is negative, means that like one of them is negative. If the number is positive, what it means? It means that either both are negative or both are positive. So there is no dependency on the multiplication. It could be both positive, negative. So what you can do, you can simply find out the max two number to its absolute value. So what you can do, you can change a to absolute value of a. So just replace all the numbers to its absolute value, because there is no dependency of positive or negative. The numbers could be fine, like so either positive or negative. So just replace a with the absolute value and find out two max values. Let's say one is mx1, max1, and max2, right? So this max1 and max2 would be unreplaced, and let's consider max3 is the third max number in this. So what you can do, you can replace a to its absolute value of a, then you can sort it. Just sort the given array, then find out max 1, the maximum value which would be a of n minus 1. Similarly, max 2, that will be a of n minus 2, the second max, and let's say the third max 3 is equal to a of n minus 3, right? What we will do, we will replace this number, like we won't be touching these two numbers because these two are the max result in this array A. So these two are the unreplaced number, and we will replace max 3 with either minus 10 to the power 5 or 10 to the power 5 based on the multiplication of max 1 and max 2, right? So yeah, I hope you understand this problem. What we can do, we can first change a to its absolute value of a, then we can find out max 3 numbers, max 1, max 2 and max 3. So this is my max 1 and this is a max 2. We know that since we have converted a to its absolute value of a, so the multiplication of these two anyway going to be positive. So what is your answer? Your answer is going to be max 1 into max 2 into 10 to the power 5. This is your answer, because here we have already we know that the answer is always going to be positive. We can always make the answer positive by either multiplying with minus 10 to the power 5 or 10 to the power 5 based on the multiplication of two unreplaced number, right? That's why we know that the number is going to be positive. Then just find the positive max number. So the max positive number is going to be 10 to the power 5 and multiply with max 1 and max 2. So this is the maximum number which you can achieve, right? So yeah, I hope you understand this explanation part. If you have any difficulty, please try to comment, I'll resolve it. So now let's look at the code. Here is the code of second problem. This is your nums array. This is my size. Then what I have done, I have replaced all the numbers to its absolute value. So I have I have gone through all the numbers in this nums array. If the number is negative, make it positive, right? So what it will do, it will replace all the negative numbers to its positive number. Then I have sorted it. Then I have find out the max two numbers, so max 1 and max 2, because I know that the number is always going to be positive and the result is always going to be max 1 multiplied by max 2 multiplied by 10 to the power 5. So this is your answer. So yeah, this is all about second problem. Now let's look at the third problem. In third problem, you are given two integer arrays of size 2. D consists of d1 d2 and r consists of r1 and r2. Now there are two delivery drones that are tasked to completing a specific number of deliveries. So drone I has to complete di delivery. Now is delivery takes exactly 1 hour and exactly one drone can make a delivery at any given hour, right? So both cannot make the delivery at the same time. Now additionally, both drones requires charging at a specific interval during which they cannot make delivery, right? So there is a specific interval during which they cannot make any delivery and they have to be charged. Now drone I must recharge every ri hours, so every multiple of ri 2 ri 3 ri and so on. What we have to do, we have to find out an integer that denotes the minimum total time required to complete all deliveries, right? So let's try to understand from one of the test case. So your di is 3 1 and r is 2 3, right? So the first drone delivers at hours 1, 3 and 5, because we know that it has to charge at a multiple of 2. So like it has to charge as 2, 4, 6, 8 and so on, right? So what are the free hours you have? 1, 3 and 5, right? For 3 deliveries. And similarly for this, like we know that the second drone has to be charged at a multiple of 3. So 3, 6, 9, 12 and so on. And since it just have to make one delivery, so it can anyway deliver at R2, because at R2 the first one would be charging, and we know that at any particular hour both cannot make delivery at the same time. That's why, because we know that at time 2 the first one would be charging, so we can make delivery at R number 2 for the second drone, because we have to minimize the total time, right, so that all delivery can be completed. So that's why the minimum hour is 5. And similarly in the second test case, if you see here 1 3 2 2, so here the first drone would be charging at 2 4 6, and similarly the second drone also be charging at 2 4 6, because both had same ri, right? So since both would be charging, so the first drone has to make one delivery, so it can make the delivery at hours 1 3 5 7, and similarly here it would be making delivery again 1 3 5 7, exactly same. So what you can do, you can make the delivery at time 3 for the first one and then 1 5 7 for the second one. So the minimum time would be 7 hours. So yeah, I hope you understand. Just spend some time to like try to understand the test case. So yeah, it's a good problem. Let's see how we can approach it. This problem number 3 can be solved using binary search. I'll tell you why. So let's say there is a time graph t, and I want to find out whether for the particular time t both the drones can make the deliveries or not. Let's say for this particular time t, the drones are okay to make the delivery, like they can make the delivery for the time t. What it means, if I go beyond t, they will always make the delivery for sure, because if any particular time t, if like, so if for that particular time t, if they can make the delivery, let's take an example, let's say for time 6, like at time 6 they can make the delivery, like by the time you reaches 6 they can make the delivery. What it means, for the time 7, 8, 9, 10, like for the larger time they can anyway make the delivery, right? So if they are okay to make the delivery by the time 6, they can make the delivery easily by the time 7, 8, 9 and 10, right? So all these are true, so this true will tell you yes, they can make the delivery. If it is false, they cannot make the delivery. And similarly, let's say there is a time when um, where they cannot make the delivery. Let's say that time is something like t dash false. So this is the first occurrence where you hit the false. So before that you will always be getting false. So let's say there is a machine, and this machine takes 6 hours to finish its job. So if you have just 5 hour, 4 hour, 3 hour, I mean the less than 6 hour, it cannot finish its jobs. That's why if for any particular time t days, if you cannot make the job, if the both drones cannot make the complete delivery, it cannot make delivery for the smaller time, right? So, and in these kind of behavior where you have some time where you can make the delivery, and after that you can always make the delivery, and before that we cannot make the delivery, for these kind of problems is solved using binary search. So what we will do, we will apply a binary search here. So the initial low value, let's say I have taken 0, right? And high value which I have taken, let's say some very large value, 2 to the power 18, for example, 2 into 2e18. So this is nothing but 2 into 10 to the power 18, right? So what I will do, I'll try to find the mid value here. I'll apply binary search here. I'll try to find the mid value, and for that mid value I will check if by the time mid, if both drones can make the delivery or not. Let's say let's say by the time mid, they can make the delivery. What it means, it means that by the time mid plus 1, mid plus 2, they can always make the delivery, right? So in that situation, go to the left half, right? Because we have to find out the minimum total time. So if they are, like if both the drones can make the delivery by the time mid, it means that they can they can always make the delivery by the time mid plus 1, mid plus 2, mid plus 3 and so on. So go to the left half, right? So go to in the range low to mid minus 1. Yeah, I hope you have solved at least one binary search problem, so then only you understand. Now let's assume the second case. If they cannot make the delivery by the mid time, what it means, if they cannot make the delivery by the mid time, then they can also not make the delivery by the time mid minus 1, mid minus 2, mid minus 3, right? The left values. So in that situation, go to the right half. The right half is from mid plus 1 to high value, right? Yeah, I hope you understand how this pseudocode would look like. So now our only job is to find out whether to check if the both drones can make the delivery by the time this mid, right? So let's say that mid is t, I'll call it t, because in my explanation part. So yeah, I hope you understand this explanation. Now the only job left is to how to check whether both drones can make the delivery by the time this t or mid. So let's see how we can check that. So what we can do here, let's say for the time t, right? So what are the times we have? We have 1, 2, 3, 4, 5, 6, 7 and so on up till time t, right? And we know that the first drone would be charging at time ri, the multiples of ri, right? Ri, 2 ri, 3 ri, 4 ri and so on. And similarly d2, like drone 2 would be recharging at time r2, 2 r2, 3 r2, right? So what it means, for drone number 1, how much time it will take how much time it will take to make the delivery. We know that like out of these time from 1 to t, there are certain times when drone number 1 would be recharging, and how much that, t divided by r1, right? T divided by r1 is the time, like all the times when the d1 would be charging. So how much time you left with t minus t divided by r1, right? The total time minus t divided by r1 is the time when the drone number 1 would be recharging. Similarly for drone number 2, like it will be recharging at from time t1 to r2, and just subtract it from the total time. So these are the times when drone number 2 can make the delivery, and these are the times when drone number 1 can make the delivery, right? But the only problem here is that both, I mean, like only one drone can deliver per hour, right? So per hour, like either drone 1 will deliver or drone 2 will deliver, so we cannot just simply sum them. So we will also have to find out those times when both would be charging, right? So that time would be, let's say that is when both are charging. So when both d1 plus d2, so when both would be charging, that time is t divided by LCM of r1 and r2. So this is the time when both would be charging, and t minus is the I mean, like if you just subtract that from t, then this is the time when d1 and d2 both can deliver, right? So these are the bad times when both would be charging. Let's take an example. Let's say your r1 is 2 and r3 is 3. Like so this is my r1, this is my r2, for example. So what it means, it means that drone number 1 would be charging at 2, 4, 6, 8, 10, 12, and so on, right? Similarly drone number 2 would be charging at time 3, 6, 9, 12. See, these are the common times, right, when both would be charging. So that's exactly what I have done here. I have find out like what are the times for the time limit t when both d1 and d2 would be charging. So that is t divided by, so this is LCM of r1 and r2. The LCM of r1 and r2 is nothing but 6. See, 6, it's a multiple of 6, 6, 12, then the next would be 18, then 24, and so on. So that's what I have found out. Now this is my d1 plus d2. Now the job is easy. If you want to check if by the time t, if both the drones can make the delivery or not, you can simply check if d1 is less than or equals to let's say this is my, for example, t1, and this is my t2, and let's call this number as t3, for example. So your d1 must be less than or equals to t1, and your t2, your d2 must be less than or equals to t2, and your d1 plus d2 must be less than or equals to t3. If this condition holds true, then both the drones can make the delivery. Let's see how. What is this d1? D1 is the time, so d1 is the number of deliveries which drone number 1 have to make, right? And we know that by the time t, you have these many times left where your drone number 1 can make the delivery. So this is the number of deliveries that d1 has to make, right? Like drone number 1, and this is the time you have to make the delivery. So your d1 must be less than or equals to t1. Similarly, for drone number 2, this is these many number of deliveries drone number 2 has to make, and t2 is the time you have when you can make the delivery. So d2 must be less than or equals to t2, and this d1 plus d2, right? So we know that at a time only one can make the delivery, right? So this is kind of like mutually exclusive, both cannot make the delivery at the same time. So we know that the delivery time would be distinct for drone number 1 and drone number 2. They cannot make the delivery at the same time. That's why d1 plus d2 must be less than or equal to t3, and t3 is the time you have when both are available, because we know that LCM of t divided by LCM of R1 and R2 is the time when both would be charging. So just subtract it from t, and this is my T3. So D1 plus D2 must be less than or equal to T3. If all these three condition holds true, it means that by the time t, both D1 and D2, like both row number 1 and row number 2 can make the delivery. Yeah, that's all about the explanation part, and we already discussed how to apply binary search, right? So yeah, that's all about explanation, and if you have any difficulty, please write a comment. This is the code of third problem. This code is written exactly how I have explained in the explanation part, so I would highly recommend to check out the explanation part first. So yeah, let's dive in. So this is my D1, D2, R1 and R2, right? And this is the standard binary search implementation. This is my low, this is my high, and this is my answer. Now while low is less than or equals to high, find the mid value. Here what I am doing, I want to check if by the time mid both the drones can make the delivery or not. If they can make the delivery, if they can finish the delivery by the time mid, it means that this is one of your potential answer. So this is one of your answer. Now we know that if both drones can make the delivery by the time mid, they can also make the delivery by the time mid plus 1, mid plus 2, mid plus 3. So like no need to go to the right half, go to the left half. So your high become mid minus 1. Else if they cannot make the delivery, it means that they cannot make the delivery for the smaller time, mid minus 1, mid minus 2. So go to the right half. So here your low become mid plus 1. So no need to go to the left half, go to the right half, right? So and at then return your answer. So let's see how this can function can be find out. So this formula is exactly explained in the explanation part how. So what I have done here, I want to find out the time when the first drone would be recharging, that is t divided by R1, right? And if you subtract from t, so this is the available time when D1 can make the delivery, drone number 1 can make the delivery, right? So this is the time when drone number 1 can make the deliveries. Now similarly for T2, this is the time when drone number 2 can make the delivery, and t divided by R2 is the time when drone number 2 would be recharging, right? So this is the available time for T2, and T3 is the time when both can make the delivery, because we know that for LCM of R1 and R2 both would be recharging, right? Because like there could be multiple also, right? Like for example, so let's say R1 is 2 and R3 is 3. So for time 6, then 12, right? So these are the time when both would be recharging, right? So these are common times. So and for t divided by LCM of R1 and R2 is the time when both would be recharging, and if you subtract it from t, so T3 is the time when both can make the deliveries. So you just have to follow this condition. Your D1 must be less than or equals to T1, because D1 is the number of deliveries that drone 1 has to make. So that must be less than the total available time, right? So D1 must be less than or equals to T1, D2 must be less than or equals to T2, and D1 plus D3 must be less than or equals to T3, right? So if these three condition holds true, it means that both the drones can make the delivery by the time if t, right? And to find the LCM, I have used the standard formula A divided by GCD of A comma B into B, right? So yeah, that's all about the explanation and code. So yeah, let's look at the fourth problem now. In problem 4, you are given two strings as and target, each of length n, and both consist of lowercase English letters. We have to find out the lexicographically smallest string that is both a palindromic permutation of s and is strictly greater than target, right? If there is no such permutation exists, we have to find out, like just return the empty string, right? And we know what is permutation and we know what is palindrome. So it's nothing but we have to find out the lexicographically smallest permutation of this string as, which is which is a palindrome and also more than the target value, right? Which is strictly greater than the target. Yeah, it's a good problem. It's actually an implementation problem. I have almost written the code. It is accepted, but I didn't make the video yet. So if you need the explanation for the fourth problem, please write a comment. I'll make a separate video for that. It's just an implementation problem, right? Yeah, that's all about today's contest. If you find the video helpful, please like, share and subscribe to my channel. Thanks for watching.